The cosmos is far more bizarre, more magnificent, and more infinitely vast than our minds can ever truly interpret. Right now, humanity is taking its very first tentative steps into the grand exploration of our immediate solar system. Our advanced machinery and engineering have finally touched down on incredibly distant worlds. Incredible breakthroughs in science and technology are now allowing us to pull back the curtain on what truly exists outside our own cosmic backyard. We are uncovering radical, hostile planets and majestic stellar masterpieces that have been moulded over millions of years. Today, we embark on an epic voyage through the deep trenches of outer space, travelling directly into the most bewildering and shocking regions of the explored universe. Over the course of this journey, we are going to present the absolute most grand, jaw-dropping and violently extreme phenomena that take place across the entire theatre of creation. Our first destination brings us directly to Mars, famously known as the Red Planet. This world is immediately identifiable by its distinct crimson shades, a global colour palette that is fundamentally caused by the heavy presence of iron oxide rusting across its rugged exterior dust. Because of its proximity and fascinating traits, it stands as one of the absolute most deeply researched and rigorously monitored celestial objects orbiting within our solar neighbourhood. Despite being roughly half the physical scale of our own planet Earth, this mysterious desert sphere has completely possessed the human imagination and fueled our curiosities for multiple generations. A succession of highly sophisticated robotic rovers deployed by NASA, which prominently include the legendary explorers Opportunity, Curiosity and Perseverance, have successfully sent back an absolute treasure trove of critical scientific data detailing the Martian atmospheric patterns and its complex structural geology. Looking closely at the imagery sent back, we are treated to an incredibly stunning and highly detailed view of the massive formation known as Belva Crater. This breathtaking visual perspective was carefully recorded by the Perseverance rover, utilizing its highly advanced state-of-the-art panoramic imaging array. This specific impact scar is situated directly inside the borders of the gargantuan Jezero crater. Jezero was intentionally selected as the fundamental primary target zone for the entire exploration mission because scientists believe its ancient history holds the highest statistical probability of harbouring fossilised proof of ancient microscopic life. As it traverses other sections of the planetary landscape, the Perseverance rover has continually captured and archived images of highly enigmatic rock outcroppings and bizarre, anomalous geological layouts. For instance, a beautifully expansive panoramic scene was previously captured by the older Opportunity rover while it was stationed at a location named Greeley Haven. The rover was forced to park at this precise spot to survive the brutal and freezing winter season that grips the southern hemisphere of the planet. The surrounding environment is visibly defined by a highly rugged, rust-coloured and stone-littered floor. This ground features a remarkably jagged texture, and you can clearly see the distinct geometric tracks left deep in the Martian soil by the heavy wheels of our machinery as it rolled across the surface. Gathering this immense wealth of data from these automated journeys has proven to be completely vital in determining whether Mars possessed the necessary environmental factors to sustain biological entities in its ancient past, while simultaneously allowing us to map out and coordinate upcoming crewed missions to the planet. Carved deeply into the region near the Martian equator is Valles Marineris, an absolutely massive chasm that easily ranks as one of the single largest canyon networks found anywhere in the known solar system. To put its mind-boggling scale into perspective, this geological scar runs for a distance that is 10 times longer than the United States Grand Canyon, and it drops to a depth that is a staggering 3 times deeper than that iconic Earth landmark. Furthermore, if you travel over to the western hemisphere of the Red World, you will find yourself standing before Olympus Mons, which is officially classified as the absolute tallest volcanic structure discovered in our entire solar system. This monumental peak reaches an altitude of 22 kilometers, which translates to roughly 14 miles in height. That means this colossal feature stands nearly 3 full times higher than the peak of Mount Everest. This particular geological behemoth is categorized as a shield volcano, and its massive footprint was built up entirely by continuous, slow-flowing eruptions of liquid lava that gradually coated the surrounding crust over vast stretches of time. When it comes to satellites, Mars is orbited by a pair of minor, oddly shaped moons that are officially designated as Phobos and Deimos. These names were directly derived from the mythological twin sons of the ancient Greek god of war. Phobos happens to be the physically larger of the two companions, and it maintains a much tighter orbital path to the planet. Because it is so close, it races through space fast enough to execute 3 complete revolutions around Mars in the span of just one single Martian day. On the other hand, its sibling Deimos, which circles the planet at a drastically further distance, requires approximately 30 hours to finish just one full lap around the world. If you look at the extreme northern and southern polar zones of Mars, you will find thick, stratified caps of ice. These polar fields are comprised of a mixture of solid water ice along with massive amounts of frozen carbon dioxide, which is more frequently referred to on Earth as dry ice. Throughout the peak of the warmer Martian summer season, a significant portion of this frozen carbon dioxide completely bypasses the liquid state and sublimates straight into an atmospheric gas. However, this gas eventually precipitates back down and refreezes into a solid sheet the moment the freezing winter temperatures inevitably return to the poles. Leaving our planetary neighbours behind, we travel out to the spectacular Eagle Nebula, glowing brightly within the stellar boundaries of the Serpens constellation. This incredibly active star-producing cloud is situated roughly 7,000 light-years away from our home planet. The intense, blistering radiation flowing outward from the gargantuan stars born within this cloud sparks truly unique cosmic phenomena. The most famous example of this is the breathtaking structure known as the Pillars of Creation. This radiation acts like a cosmic chisel, sculpting absolutely mesmerizing and haunting shapes by slowly eroding the surrounding fields of cold gas and dark interstellar dust. These grand cosmic towers are so massive that they span between 4 and 5 full light years in total length. This length represents a physical distance that is roughly 30,000 times greater than the entire space separating the Earth from the Sun. The internal composition of these pillars consists primarily of cold molecular hydrogen gas mixed with fine interstellar dust particles, providing the exact fundamental raw ingredients required to spark the birth of brand new stars. Next, we redirect our focus toward the centerpiece of our own solar neighborhood, the Sun. Even though it is scientifically classified as a completely average, middle-aged star when compared to the rest of the universe, it possesses very specific dynamic traits that make it absolutely vital and unique to us. Operating under the careful observation of NASA's sophisticated Solar Dynamics Observatory satellite mission, modern astrophysicists have gained the ability to monitor its violent surface activity in unprecedented, ultra-high definition clarity. Our parent star is structurally categorized as a yellow dwarf that is currently residing in the stable, main sequence phase of its long stellar life cycle. At its crushing core, it continuously and reliably fuses vast quantities of hydrogen gas. This incredible long-term stability is the exact factor that has permitted organic life on Earth to grow, adapt and flourish for billions of continuous years, thanks to an incredibly reliable and steady radiation output. While it may not be considered a true giant when measured against the largest stars in the deep cosmos, the Sun is still vast enough that you could easily hollow it out and pack 1 million Earth-sized worlds right inside of it. On occasion, the star experiences monumental solar eruptions that explode outward to jaw-dropping distances, sometimes extending into space at a length that equals nearly 8 times the entire diameter of our home planet. During its cycles of maximum magnetic activity, the Sun violently throws off truly astronomical amounts of highly energized, charged particles directly into the vacuum of space. When these particle streams slam into our planet's magnetic shield, they ignite the atmosphere to form spectacular, dancing auroras across the extreme northern and southern polar skies. Some of these mind-blowing solar explosions are so distinct that researchers have given them specific titles. One prime example is an event dubbed the Trebuchet explosion, during which an enormous solar flare detonated and an immense loop of glowing plasma was seen raining back down onto the stellar surface under the pull of gravity. Moving out into the deeper interstellar void, we arrive at the breathtaking Carina Nebula, resting roughly 7,500 light-years away from our vantage point on Earth. This breathtaking celestial masterpiece is found within the boundaries of the southern constellation Carina. The highly advanced James Webb Space Telescope has captured breathtaking new views of this region. These images expose incredibly complex and fine structural details that were completely veiled from our sight in the past by the dense, opaque walls of the gas cloud. Deep within these cosmic cliffs, incredibly young and profoundly massive stars are actively pulling themselves together. As they ignite, they release fierce torrents of stellar energy that aggressively carve and shape the surrounding canvas of dust and hydrogen gas. You can clearly see high-velocity columns and jets of gas blasting away from specific sections of the nebula. These cosmic blowtorches originate directly from the highly intense, chaotic stellar dynamics occurring deep within the heart of the cloud. Our journey now takes us to the most terrifying objects in existence, black holes. In the month of April 2019, history was permanently altered when the first actual photograph of a black hole was successfully recorded. This monumental leap forward for human astronomy was achieved through the global coordination of the Event Horizon Telescope project. The primary target for this historical observation campaign was the supermassive black hole anchoring the centre of the giant Messier 87 galaxy. This specific target was chosen because the surrounding cosmic environment was exceptionally clear, allowing for the best possible visibility. Closer to home, at the very heart of the Milky Way Galaxy, lies Sagittarius A, our own resident supermassive black hole, whose true visual form has also recently been revealed to the world. The brilliant glowing ring of light that stands out in these images is known as an accretion disk. This is a violently swirling cosmic whirlpool composed of superheated gas, crushed dust, and various debris moving at fractions of the speed of light. As passing light beams glide close to the borders of the black hole, the light itself becomes severely twisted and warped. This distortion happens because the sheer mass of the object heavily curves the literal fabric of space-time. The boundary known as the event horizon represents the definitive point of no return. Once anything crosses this invisible threshold, the gravitational pull becomes so absolute that not even light can escape its grasp. Past this terrifying boundary lies the singularity. This is an infinite point where all our current understandings of physics completely break down, and what truly transpires at this coordinate remains an absolute mystery. Certain theoretical models propose that these objects might act as cosmic gateways, linking to entirely separate sectors of our universe, or perhaps even bridging into entirely different dimensions, though these ideas remain strictly speculative. Among the absolute largest supermassive black holes ever found by our instruments are absolute monsters like TON 618, Phoenix A and SDSS. Each of these gargantuan anomalies possesses an internal mass that is equivalent to tens of billions of our suns combined. Situated at the deep gravitational centres of their host galaxies, these ancient cosmic titans originally developed during the dawn of the early universe, and they are fully capable of erupting with unimaginably violent jets of highly accelerated matter. Next, we travel 1,400 light-years away from Earth to visit Kepler 452b. This fascinating exoplanet is routinely referred to by astronomers as Earth 2.0 because it shares a series of truly remarkable characteristics with our native world. It is positioned directly inside the habitable zone of its solar system, meaning it orbits its parent sun-like star at a physical distance that closely mirrors Earth's own path. It takes this world roughly 385 days to complete one single year. The atmospheric cloud decks blanketing Kepler 452b are projected to be exceptionally heavy, misty and dense, completely shrouding the vast majority of the world's surface when observed from outer space. Because it holds a mass that is roughly 5 times greater than Earth's, this planet likely generates a massive amount of internal thermodynamic heat. If it is indeed a solid rocky world, this immense internal heat would inevitably trigger a truly violent degree of global volcanic activity. If this scientific theory is correct, the landscape would be completely dominated by countless erupting volcanoes, featuring massive rivers of glowing lava and colossal plumes of dark volcanic ash billowing high into the atmosphere. These microscopic volcanic particles, when mixed into the planet's heavy atmospheric gases, would bend and scatter incoming starlight so intensely that every sunrise and sunset on this world would burn with an incredibly deep, saturated blood-red glow. If any form of biology has managed to take root on the surface of Kepler 452b, it would almost certainly look drastically different from the life we are familiar with on Earth. It would be a foreign biome that pushes the boundaries of our imagination, yet it remains completely thrilling to analyse. The world's heavy surface gravity, combined with the dim starlight filtering through the endless blanket of thick clouds and the constant threat of volcanic disruptions, would heavily dictate the evolutionary traits of any native species. For example, a theoretical organism classified as Lumiverax kepleri, which translates to the luminous tower, could exist as a massive, bioluminescent plant-like structure. It would evolve to grow to incredible heights just to catch the very faint, heavily filtered starlight that manages to break through the dense atmosphere. To survive the crushing gravity of the planet, this organism would feature an incredibly dense, highly reinforced fibrous trunk, anchored by a deep root network designed to pull vital minerals directly out of the rich volcanic soil. Another fascinating creature could be Nectomysta nebularis, a unique floating vine made entirely of highly porous, lightweight biological tissues. This organism would be perfectly engineered to drift through the world's thick, incredibly humid, low-lying atmosphere. It would harvest its moisture and vital atmospheric nutrients directly out of the foggy air by using specialised sponge-like aerial roots that hang suspended in the mist. We can also imagine Ruminator obscurus, a heavy ground-dwelling herbivore equipped with a complex array of multiple stomachs. this highly specialised digestive tract would be completely necessary to break down and process the incredibly tough, fibrous plant matter native to Kepler 452b. The outer skin of this beast would be completely covered in a glowing layer of symbiotic lichens. Deep beneath the planet's burning crust, you might find Ignivermis lavae, a subterranean giant worm that actively tunnels through the subterranean volcanic channels, feeding directly on the molten magma. Its heavily reinforced heat-defying body would emit an intense crimson glow, serving as a biological warning sign to keep potential predators at bay. Finally, there is Umbraque oris, a land predator that sports incredibly oversized ears. This creature evolved these massive auditory appendages to pinpoint micro vibrations travelling through the rocky ground. It relies entirely on sound waves to navigate its environment, as the planet's permanent heavy fog banks make traditional eyesight almost completely useless. The Rosetta spacecraft uncovered an extraordinary secret on the surface of comet 67P Churyumov-Gerasimenko, detecting intricate and complex organic building blocks. Among these critical components were amino acids such as glycine, alongside vital chemical elements like phosphorus. This monumental finding heavily reinforces the scientific hypothesis that primordial ice bodies and roaming comets may have originally supplied the foundational chemical ingredients necessary to spark the development of life on a very young, newly formed Earth billions of years ago. Turning our attention to captured motion pictures of this roaming ice island, we are given a stark, up-close view of the comet's rugged exterior shell. The entire layout is deeply layered with thick coatings of cosmic dust, all while fine lines of highly energetic cosmic radiation continuously zip and flash through the frame like tiny subatomic shooting stars. Floating like a ghost through the vast empty corridors of the interstellar void is a breathtaking structure known to astronomers as the Red Ribbon. This magnificent glowing filament of crimson light serves as a historic echo across the ages, marking the exact coordinates of a truly gargantuan stellar detonation that originally shattered the night sky in the year 1006 within the boundaries of the Lupus constellation. This catastrophic event was an incredibly brilliant, historically unprecedented supernova explosion. It was so extraordinarily luminous that it was clearly documented by ancient skywatchers across the globe, with detailed historical accounts preserved by Chinese, Japanese, Arab, and European astronomers who all marvelled at this temporary new star. The gorgeous red line we observe today is actually a structural segment of the supernova's rapidly expanding blast wave. This celestial shock wave consists of ambient interstellar gas that has been violently compressed, superheated to extreme temperatures, and completely ionized by the immense physical energy unleashed during that ancient stellar collapse. Far out in the deep stellar ocean, we discover an incredibly bizarre alien world named Tres 2b. This distant gas giant has earned a terrifying reputation among scientists as the single darkest exoplanet ever identified in the entire history of astronomy, possessing an albedo so exceptionally low that it reflects less than 1% of all the incoming starlight that strikes its atmosphere. The underlying physical mechanism behind this absolute pitch-black darkness remains a profound scientific puzzle that researchers are still actively trying to solve. However, the leading theoretical consensus suggests that its deep atmospheric layers are highly saturated with specific light-absorbing chemical elements and vaporized compounds that swallow photons whole rather than bouncing them back out into space. Despite this near-perfect internal darkness, the world is not completely invisible to our instruments. Because it orbits dangerously close to its parent star, the planet traps a truly staggering amount of thermal energy, which likely causes its heavy atmosphere to give off a very faint, ominous crimson glow that seeps out from the darkness, like burning embers. We now bring our journey back toward our immediate neighbourhood to gaze upon the breathtaking majesty of Saturn. This majestic gas giant is structurally comprised almost entirely of primordial hydrogen and helium gases. In this structural sense, it shares a very close chemical relationship with its largest sibling Jupiter. Yet Saturn possesses a much lower physical density, making it the least dense planet in our solar system. Without question, its absolute most recognizable and visually stunning characteristic is its magnificent, iconic planetary ring system. This wide cosmic highway is not a solid structure, but is instead made up of trillions of independent ice shards, frozen water fragments, and rocky dust particles, all swirling in a perfectly balanced orbital dance. Saturn operates like a crowded miniature solar system all on its own, boasting an incredibly diverse family of 145 officially verified moons. These natural satellites vary wildly in their overall scale, geological landscapes, and chemical compositions. The crown jewel of this planetary family is Titan, which easily ranks as the absolute largest moon in Saturn's orbit. Titan stands completely unique among all moons in the solar system because it is heavily wrapped in a dense, thick, nitrogen-rich atmosphere that contains strong traces of gaseous methane and complex hydrocarbon haze. The environmental conditions on its surface are truly surreal, featuring active weather systems that carve out networks of flowing rivers, carving deep valleys that empty into wide lakes, and expansive seas filled with liquid methane and ethane. Furthermore, planetary scientists strongly suspect that a massive global ocean composed of liquid water remains hidden deep beneath this world's frozen outer crust. Another fascinating member of this lunar family is Enceladus. Though it is significantly smaller than Titan, this tiny ice world has completely captivated the scientific community due to the dramatic plumes of pressurized water vapor, ice crystals, and organic molecules that continuously erupt out of deep fractures in its southern polar shell. The surface of this moon is highly dynamic, decorated with an intricate network of deep cracks, tectonic folds, and icy ridges. These structural features offer clear, undeniable evidence of powerful ongoing geothermal and tectonic activity churning deep within its interior. Our exploration now shifts to analyse the mechanics of supernovas, which stand as some of the absolute most violent and energetic events in the known cosmos. These monumental explosions represent the definitive, catastrophic end phase of a supermassive star's life cycle, though they can also be triggered within a tight binary star system when a white dwarf pulls too much matter from its companion. During these cataclysms, an absolutely unimaginable torrent of raw stellar energy is unleashed into the void in an instant. In the immediate days following the initial blast, these dying stars reach their absolute peak brightness, erupting with so much light that they can easily outshine an entire galaxy of billions of stars. If one of these events occurs relatively close to us within the borders of the Milky Way, it can become so brilliantly luminous that it can be seen clearly with the unassisted human eye during broad daylight. During the height of a supernova explosion, the core of the parent star undergoes a crushing gravitational collapse so intensely violent that the literal structure of individual atoms is completely shattered. This extreme compression forces protons and electrons together, which can ultimately lead to the creation of either an incredibly dense neutron star or a bottomless supermassive black hole. Long after the initial flash of light fades away, the stellar debris and heavy elements cast off by the explosion continue to expand outward into space over thousands of years, gradually forming a gorgeous glowing nebula known as a supernova remnant. A premier example of this phenomenon is Cassiopeia A, This spectacular, colourful cloud is the expanding remnant of a massive star that exploded roughly 300 years ago within the northern constellation of Cassiopeia, providing modern astronomers with a perfect laboratory to study the death of stars. We now travel roughly 1,100 light-years away from our home planet to investigate a highly tantalizing exoplanet candidate designated as KOI 4878.1. Although it still awaits definitive scientific confirmation, preliminary data indicates that this alien world might actually be the absolute most Earth-like planet ever detected in the deep cosmos. This intriguing world takes approximately 449 Earth days to complete one full revolution around its parent star. It possesses a physical mass that is somewhat larger than our native world, which directly implies that a human standing on its surface would experience a slightly heavier degree of surface gravity. Furthermore, this exoplanet maintains an orbital path that places it at a notably further distance from its host star than the Earth sits from the Sun. Because of this increased distance, if its atmosphere lacked insulation, it would be a cold desert. However, if its atmosphere contains a rich concentration of natural greenhouse gases, it could easily trap enough thermal energy to maintain a beautifully balanced, moderate global climate that closely mirrors our own. Under this fascinating hypothetical scenario, the world would likely be a stunningly beautiful sphere covered in vast, deep liquid oceans, dramatic frozen polar ice caps, and expansive, lush continents stretching across its temperate geographical zones. If KOI 4878.01 is eventually validated by our telescopes, these highly stable environmental factors mean it would possess an incredibly high probability of nurturing some form of alien biology. Because its parent star is slightly different and further away, the surface of the world would be illuminated by a starlight that is noticeably dimmer and softer than the bright daylight we enjoy on Earth. The native species of this planet would be heavily shaped by a dynamic environment defined by shifting global temperatures, regions of intense stellar radiation, deep permanent shadows, and highly active global plate tectonics. Looking closely at how life might adapt to KOI 4878.01, we can imagine a botanical organism called Flammifolia. This unique, low-profile plant would grow close to the ground to resist the heavy gravity, featuring beautifully spiraled leaves that shimmer with a brilliant golden coloration to efficiently capture the specific wavelengths of its parent star's starlight. Prowling through the shadows of this world would be a terrifying apex predator known as Obscuravox. This creature would evolve an incredibly specialized pitch-black skin layer that completely absorbs all incoming light, causing the animal to look like a living, moving silhouette, with no visible facial features or body details. Thanks to this absolute light-absorbing camouflage, the predator can seamlessly melt into any dark corner or shadowed landscape, rendering it completely invisible to its prey. Even if the creature steps directly out into the open starlight, it remains remarkably difficult to spot because its unique hide reflects absolutely no shine or glare. Sharing this ecosystem is Pteroclypus, a massive, slow-moving quadrupedal herbivore. To defend itself from predators like the Obscuravox, it is heavily armoured with a complex segmented shell that is structurally engineered to bend and deflect incoming light rays, providing it with a form of defensive visual distortion. This gentle giant spends its days migrating across the rolling hills and wide plains, feeding continuously on the thick, nutrient-rich leaves of a native plant called Absorbiluxa. We also find Cresta solaris, an elegant four-legged creature that travels in highly coordinated social herds. These animals feature a prominent glowing biological crest running along their heads, which they use to flash complex light signals to communicate with one another across the dark plains. The exact colour and pulsing intensity of their bioluminescent crests serve as an open window into their internal emotional states, changing rapidly based on fear, excitement or calmness. Another fascinating mammal is Pluma ferox, an agile creature adorned with a long sweeping tail covered entirely in vibrant bioluminescent feathers. The males display these glowing feathers in complex courtship dances to attract potential mates. Beyond social communication, these oversized feathers serve an important biological purpose by helping the animal regulate its body temperature, expanding outward to radiate excess heat away in warm climates, or tucking tight against the skin to provide thick insulation in freezing environments. Finally, the violent volcanic sectors of the planet are home to inferno pellets. These stocky, low-slung organisms are built specifically to endure extreme heat, with their lower limbs completely encased in a thick, natural ceramic-like biological layer that insulates them from hot ash and burning stone. Their internal anatomy is equally rugged, possessing an incredibly resilient digestive system that allows them to drink near-boiling volcanic water without suffering any physical damage. Next, we journey out to the absolute outermost fringes of our immediate solar neighbourhood to visit Pluto. Once classified as the 9th planet, it is now officially designated as a dwarf planet residing deep within the icy realm of the Kuiper Belt, a vast and freezing ring populated by millions of ancient, frozen cosmic bodies. In the month of July 2015, human knowledge of this lonely world was fundamentally revolutionized when NASA's automated New Horizons spacecraft executed a historic, high-speed flyby past Pluto. This intrepid robotic explorer successfully beamed back the first ultra-high-definition close-up images and rigorous scientific data of its icy surface. The data shockingly revealed that this freezing dwarf planet is far from a dead world, featuring monumental mountain ranges composed of solid water ice that tower up to spectacular heights of 3,500 metres, or roughly 11,000 feet into the thin air. When viewed through our cameras, Pluto displays a very distinct rust-coloured or reddish hue across large portions of its landscape. This planetary colour palette is caused by the heavy presence of tholins, which are highly complex organic molecules that are created when the faint ultraviolet radiation from the distant sun interacts chemically with the methane gas floating in Pluto's cold atmosphere. Pluto is accompanied by a system of 5 known moons, including a small satellite named Styx. Astrophysicists believe that Styx and its sibling moons most likely formed billions of years ago in the aftermath of a colossal, catastrophic collision between Pluto and another massive Kuiper Belt object. Reversing our direction completely, we dive deep into the blazing heart of the solar system to explore Mercury. As the single closest planet to our parent star, it experiences an incredibly accelerated orbital journey, possessing the absolute shortest year of any world in our solar system, by completing a full lap around the Sun in a mere 88 Earth days. However, while it flies through space at an incredible speed, it rotates on its internal axis at an agonizingly slow pace, requiring roughly 59 Earth days just to finish one single rotation. Because Mercury completely lacks a thick, substantial atmosphere to retain heat or regulate solar energy, it is plagued by the most violently extreme temperature swings found anywhere in the solar system. During the long solar day, the surface is mercilessly baked as temperatures soar to a blistering 430 degrees Celsius, which is over 800 degrees Fahrenheit. Conversely, during the equally long night with no air blanket to trap the heat, the temperature instantly plummets down into a freezing nightmare, dropping to a bone-chilling minus 180 degrees Celsius, or nearly minus 292 degrees Fahrenheit. The rocky surface of Mercury bears a striking visual resemblance to our own moon, being completely saturated with countless impact craters. These geologic scars are the preserved records of ancient, violent asteroid bombardments that heavily shaped the chaotic environment of the early solar system. Anchoring its rugged terrain is one of the absolute largest impact structures found anywhere in the known universe, the monumental Caloris Basin, an enormous crater that measures an unbelievable 1,550 kilometers, or roughly 960 miles in total diameter. Stepping completely outside of individual solar systems and galaxies, we expand our cosmic perspective to the absolute largest structural scale imaginable to witness a galactic filament. These mind-boggling networks stand officially as the absolute most colossal structures in existence across the entire universe, stretching continuously for hundreds of millions of light years. These filaments are composed of dense concentrations of entire galaxies, vast rivers of primordial gas, and massive halos of invisible dark matter, all woven together to form a beautiful, unimaginable cosmic web that spans the entirety of creation. Within this unfathomably large cosmic grid, entire galaxies and massive galactic clusters are forced to organize and align themselves directly along the pathways of these filaments. Because matter is pulled tightly into these highways, this structural arrangement leaves behind absolutely gargantuan, empty expanses of pure nothingness, known to science as cosmic voids, which contain virtually no galaxies at all. Cosmologists believe that invisible dark matter actually provides the overwhelming majority of the physical mass anchoring these cosmic structures. This hidden matter generates the intense, long-range gravitational pull that acts like a cosmic glue, holding these grand filaments together across the fabric of space-time. We now return our focus to the planetary realm to study Uranus, the highly enigmatic seventh planet from the Sun. This frozen gas giant is instantly recognizable across the astronomy community due to its highly unique, beautiful bluish-green color and its completely extreme axial tilt. Unlike any other planet in our solar neighborhood, Uranus is tilted so far on its side that it essentially rolls around the Sun like a bowling ball. This severe anomalous orientation creates a truly bizarre seasonal cycle where each geographic pole is forced to experience 42 continuous years of uninterrupted blinding sunlight, followed immediately by 42 years of absolute frozen darkness. The planet's heavy atmosphere is composed primarily of hydrogen and helium, but it also contains significant traces of methane gas. This methane plays a critical role in the planet's appearance, as it selectively absorbs incoming red light wavelengths, while reflecting the blue and green light back to our telescopes. Encircled around this giant world is a delicate minimalist system of 13 narrow planetary rings, which are comprised of ancient ice particles mixed with incredibly dark light-absorbing dust. Uranus boasts a large family of at least 27 known moons, which hold a unique cultural distinction because they are all named after famous literary characters chosen from the classic works of William Shakespeare and Alexander Pope. Among this diverse collection of moons are prominent worlds such as Titania, Ariel, and the geologically shattered Miranda, sailing out 28 million light-years away into the deep intergalactic ocean within the borders of the Virgo constellation. We encounter the breathtaking Sombrero Galaxy. This magnificent stellar metropolis stands out as an absolute visual marvel because its specific shape bears a truly striking, uncanny resemblance to a traditional Mexican sombrero hat. Structurally, it is classified as an exotic spiral galaxy that features an exceptionally sharp, perfectly defined outer dust disk paired with an enormous, brightly glowing central stellar bulge. This highly pronounced structural combination is an exceptionally rare and unusual geometric layout across the cosmic landscape. Deep at the absolute gravitational heart of this galaxy lies a terrifying monster, a supermassive black hole that possesses an internal mass equivalent to an unbelievable 1 billion of our suns combined. This immense scale ranks it comfortably as one of the absolute largest black holes ever identified anywhere in our nearby universe. Although the galaxy appears as a relatively small, compact object from our distant vantage point on Earth, its physical diameter actually spans a massive 50,000 light-years, making its total width highly comparable to the scale of our own Milky Way Galaxy. We now come home to look at our closest companion in space, the Moon. This familiar object is Earth's one and only natural satellite, and it holds a sacred place in human history as the absolute first and only foreign astronomical body to ever be physically visited by human beings. On a structural level, our Moon is unusually, exceptionally large when measured in direct proportion to its host planet. It possesses a physical diameter that is roughly 1/4 the total size of the Earth, which represents an incredibly rare and uncommon planet-to-satellite ratio within our solar system. This physical size is incredibly fortunate for us. Without the heavy gravitational stabilization provided by the Moon, Earth's internal axial tilt would fluctuate wildly and chaotically over time. These severe orbital shifts would inevitably trigger catastrophic, extreme global climate instabilities that would have likely prevented stable, complex life from ever developing on our planet. When we look up at the lunar surface, the large dark patches commonly referred to as seas or maria actually cover roughly 16% of the entire lunar landscape. These dark plains were formed billions of years ago when ancient colossal volcanic eruptions completely filled massive impact craters with smooth, dark basaltic lava. The most legendary of these zones is the historic Sea of Tranquility. This specific coordinate became permanently etched into human history in July 1969 when the historic Apollo 11 lunar module successfully touched down, allowing astronauts Neil Armstrong and Buzz Aldrin to become the first human beings to ever step foot on the surface of an alien world. Venturing back out into deep interstellar space, within the borders of the Cassiopeia constellation, we find the beautiful Bubble Nebula. This glowing celestial wonder is celebrated by astronomers because it maintains a near-flawless, highly symmetrical spherical shape that looks exactly like a delicate translucent bubble floating through space. The driving physical force behind this structure is a series of incredibly powerful high-velocity stellar winds blasting outward from a superheated, extraordinarily massive star nesting at its core. These relentless stellar winds slowly push the surrounding interstellar material outward, causing the bubble to gradually expand larger over time. The nebula displays an absolutely stunning colour palette, where vibrant shades of red, green and blue stand out across the cloud. These distinct colours serve as chemical signatures, indicating the presence of vast fields of hydrogen, oxygen and sulfur gas. These individual gases are stimulated into a high energy state, radiating brightly under the intense ultraviolet energy radiating from the dominant central star. Deep within the bounds of the Scorpius constellation, resting at a distance of roughly 40 light-years from Earth, is the exceptionally intriguing exoplanet Gliese 667 cc. This world is classified as a super-Earth because its physical mass is approximately 3.8 times greater than our home planet. it orbits safely within the habitable zone of a dim red dwarf star, which belongs to a rare and complex three-star system. Because its parent star is much smaller and cooler than our Sun, Gliese 667 c6 must orbit exceptionally close to it, completing a full revolution in just 28 Earth days. Despite this tight orbit, the planet receives an optimal amount of stellar radiation, meaning that if it possesses a stable atmosphere, liquid water could easily pool on its surface. However, because it is so close to its parent star, Gliese 667 cc is highly likely to be tidally locked. This means one side of the planet permanently faces the searing light of its star, while the other side is trapped in eternal, freezing darkness. This extreme orbital configuration would create a dramatic atmospheric boundary line known as the terminator zone, where a perpetual twilight reigns and violent global winds rage across the landscape as they balance the extreme temperatures between the hot and cold hemispheres. If any form of life managed to take root on Gliese 667 cc, it would have to evolve under the unique pressures of heavy gravity, a constant red-tinted sky, and the relentless threat of powerful stellar flares erupting from the red dwarf. If an alien biome has developed within the twilight zone of Gliese 667 cc, the native organisms would display radical evolutionary adaptations to survive these unique conditions. For instance, we can imagine a botanical marvel called the crystallis flower. This remarkable plant-like organism would grow clustered along the rocky crags, featuring thick, crystal-like petals engineered to refract and concentrate the dim red starlight directly into its core for energy production, to anchor itself against the violent winds howling across the terminator zone. The crystallis flower would develop an incredibly intricate, metallic-rich root network that chemically binds itself to the volcanic bedrock. Preying upon the smaller inhabitants of this twilight landscape would be the nocturnus stalker, a sleek, multi-legged apex predator. This creature would completely lack traditional eyes, instead relying on an incredibly advanced array of thermal imaging pits lined along its snout, allowing it to easily track the heat signatures of prey against the cold environment. Its skin would be covered in specialized sound-dampening velvet scales, making its movements completely silent as it glides through the jagged rock formations. Sharing this hostile environment is the gargantua grazer, a colossal, low-slung herbivore with a heavily armoured dome-like shell designed to deflect flying debris kicked up by the perpetual storms. This massive beast would possess a highly efficient slow-burning metabolism, allowing it to survive for long periods by feeding on the tough rubbery mosses that cover the cavern entrances. Drifting through the heavy humid air currents of the upper atmosphere, you might spot the aerovagus, a gentle gas-filled organism that resembles a living hot air balloon. This creature would survive by filtering microscopic organic particles directly out of the wind currents, using long, trailing tentacles covered in a sticky, specialized mucus. Deep within the subterranean caves, where temperatures remain completely stable, the phosphorite crawler thrives. This unique, blind invertebrate would produce a vibrant, pulsing blue bioluminescence through a complex internal chemical reaction, using the light to signal to others of its species and coordinate migrations through the dark tunnels. Finally, along the shores where the frozen wastes meet the warmer oceans, the cryopelid would establish its nesting grounds. These hardy, amphibious creatures would possess a specialized anti-freeze biological fluid running through their veins, allowing them to dive into near-freezing waters to hunt for subterranean organisms without their internal tissues crystallizing. Leaving this alien world behind, we journey back into our own cosmic neighborhood to gaze upon Jupiter, the absolute king of the solar system. This gas giant is so unimaginably massive that its total mass is more than twice that of all the other planets in our solar neighbourhood combined. Composed predominantly of hydrogen and helium, Jupiter lacks a defined solid surface, meaning an explorer descending into its depths would encounter an increasingly dense, crushing atmosphere that gradually transitions into an exotic sea of liquid metallic hydrogen. The planet's outer atmosphere is a masterpiece of fluid dynamics, decorated with distinct, colourful bands of clouds that are constantly torn by high-velocity jet streams moving in opposite directions. The absolute most famous feature on this giant world is the Great Red Spot, a colossal, raging anticyclonic storm that has been spinning continuously for at least several centuries. This monumental tempest is so vast that it could easily swallow the entire planet Earth whole without touching its outer edges. Jupiter is surrounded by an immense, complex magnetic field that is 14 times stronger than Earth's, trapping highly energized particles and creating a lethal radiation belt that poses a severe hazard to any visiting spacecraft. This planetary giant acts like a miniature solar system, hosting a massive family of 95 officially recognized moons. The most prominent among these are the 4 historic Galilean moons, discovered by Galileo Galilei in 1610, volcanic Io, icy Europa, colossal Ganymede, and cratered Callisto. Our journey now carries us far across the interstellar void to visit the Helix Nebula, one of the closest and most breathtaking examples of a planetary nebula located roughly 650 light-years away in the Aquarius constellation. This stunning celestial object is frequently referred to by astronomers and the public as the Eye of God, due to its uncanny, striking resemblance to a colossal, glowing human eye gazing out across the darkness of space. Despite the misleading historical term planetary nebula, this structure has absolutely nothing to do with planets. Instead, it represents the final dramatic life phase of an intermediate mass star very similar to our own Sun. As the aging star exhausted its core hydrogen fuel, it swelled into a red giant before violently casting off its outer layers of gas into the surrounding void over thousands of years. The intensely hot, exposed stellar core left behind, a white dwarf, now radiates powerful ultraviolet energy that ionizes the expanding shells of discarded gas, causing them to glow with brilliant hues of red, infrared, and blue. The intricate web-like structures visible within the inner rim of the nebula are known as cometary knots, which are dense clouds of cold molecular gas and dust that resemble tiny comets with tails stretching light years outward, providing critical clues to how matter behaves during a star's death throes. We now turn our attention to the Ring Nebula, another iconic and visually spectacular planetary nebula resting approximately 2,300 light-years away within the northern constellation of Lyra. When viewed through our telescopes, this celestial wonder presents a beautiful, near-perfect oval ring of glowing material that looks like a delicate cosmic smoke ring floating silently through the dark. The unique geometry of the Ring Nebula is actually a barrel-shaped cloud of gas that we happen to be viewing directly down its central axis, creating a stunning optical illusion of a flat ring. The glowing colours of the nebula reveal a complex timeline of chemical composition and temperature gradients. The outer edges burn with a deep crimson light, signalling the presence of cooler hydrogen gas, while the interior transitions into brilliant shades of green and blue, where hotter, highly ionized oxygen and helium gases dominate. At the absolute centre of this glowing ring sits the dying white dwarf star, a tiny, incredibly dense object that was once the proud core of a star that illuminated its corner of the galaxy for billions of years. This stellar remnant is slowly cooling down over trillions of years, serving as an absolute preview of what will inevitably happen to our own sun in about 5 billion years. Continuing our voyage through the deep cosmos, we arrive at the spectacular Orion Nebula, a colossal, brightly glowing stellar nursery situated roughly 1,344 light-years away within the sword of the famous constellation Orion. This magnificent cloud of gas and dust is one of the brightest nebulae in the night sky and can be seen clearly with the naked eye as a faint, misty patch on a clear night. The Orion Nebula is an incredibly active region of star formation, acting as a massive cosmic incubator where thousands of young stars are currently pulling themselves together out of the raw interstellar material. Deep within the glowing heart of this nebula lies the trapezium, a tight, bright cluster of 4 exceptionally massive young stars whose intense ultraviolet radiation completely illuminates the surrounding gas clouds. As these newborn titans blast out fierce stellar winds, they physically sculpt the nebula, carving deep valleys, dense pillars, and hollow caverns into the dark dust. Using the advanced infrared eyes of our modern space telescopes, astronomers have detected hundreds of protoplanetary disks, or proplids, surrounding the infant stars within the cloud. These spinning disks of dust and gas are the early stages of brand new solar systems, offering humanity a front row seat to observe the chaotic processes that create new planets and moons. Our next destination brings us into orbit around Neptune, the enigmatic deep blue giant that stands as the 8th and outermost planet from our Sun. This remote ice world is structurally comprised of a thick, slushy mixture of water, ammonia, and methane ices surrounding a solid, rocky core, all wrapped in a dense, heavy atmosphere of hydrogen and helium gas. The planet's striking, deep azure coloration is primarily caused by the presence of methane in its outer cloud layers, which selectively absorbs red starlight while reflecting the blue light wavelengths back out into the void. Neptune experiences the most violently extreme, catastrophic weather systems found anywhere in our solar system, with supersonic planetary winds that can whip through the atmosphere at speeds exceeding 2,100 kilometers per hour, which is nearly twice the speed of sound. In the year 1989, NASA's Voyager 2 spacecraft executed a historic flyby of the planet, discovering a massive, rotating storm system in the southern hemisphere dubbed the Great Dark Spot. This planetary tempest was similar in nature to Jupiter's Great Red Spot, though it proved to be far more unstable, completely vanishing from view a few years later, only for new dark storms to erupt in different latitudes. Neptune is encircled by a delicate, faint system of planetary rings that feature distinct, dense clumps of material known as ring arcs, where gravity keeps the dust particles tightly clustered together. The planet is orbited by 16 known moons, with the absolute standout being Triton, a massive, geologically active moon that orbits Neptune in a retrograde direction, opposite to the planet's rotation, suggesting it was once an independent Kuiper Belt object that was gravitationally captured by Neptune long ago. Deep within the boundaries of the southern constellation, Centaurus, at an unimaginable distance from our own solar neighbourhood, floats one of the absolute largest hypergiant stars ever identified by modern astronomy, Stephenson 2-18. This mind-boggling cosmic titan completely dwarfs our local sun in sheer scale, possessing an estimated physical radius that is approximately 2,000 times larger than the radius of our parent star to truly grasp the terrifying gargantuan scale of this stellar beast. One only needs to imagine placing it directly at the central coordinates of our own solar system. If Stephenson 2-18 were to replace our Sun, its outer atmospheric layer would swell outward so aggressively that it would completely engulf Mercury, Venus, Earth, Mars and Jupiter, extending its blistering physical boundary all the way out to the orbit of Saturn. This hypergiant represents an incredibly unstable and fleeting phase of stellar evolution, burning through its nuclear fuel at a truly self-destructive rate. At some point in the near cosmological future, this unstable giant is expected to finish its life cycle in a catastrophic, historically brilliant supernova explosion, violently shattering its outer shell and leaving behind a hyperdense stellar remnant, which scientists predict will most likely collapse into either a spinning neutron star or a bottomless black hole. Shifting our focus to an entirely different kind of cosmic wonder, we travel to investigate the fascinating exoplanet candidate designated as HD 189733b. When viewed from a distance through our specialised instruments, this alien world displays a strikingly beautiful, deep cobalt blue appearance that reminds astronomers of our own home planet. However, beneath this misleadingly serene sapphire blue exterior lies an absolutely terrifying environment defined by some of the most violently extreme, nightmarish weather conditions ever detected in the entire galaxy, because this massive gas giant is gravitationally locked in an incredibly tight orbital embrace with its host star. One hemisphere is permanently forced to face the searing, relentless heat of the starlight, while the opposite hemisphere is cast into a landscape of eternal, freezing darkness. This severe permanent temperature disparity between the day and night sides generates an unceasing, planet-wide atmospheric tug-of-war, fueling supersonic winds that whip around the globe at speeds exceeding 8,700 kilometers per hour to balance the planetary heat. Furthermore, the upper atmospheric layers of HD 189733b are heavily saturated with a high concentration of silicate particles. Under the blistering heat of the permanent day side, these silicates are instantly vaporized into a scorching aerosol mist, forming dense clouds that swirl across the sky. As these vaporized silicate clouds are violently dragged by the supersonic winds over to the freezing night side, the temperature drop causes the silicates to rapidly condense, resulting in a relentless horizontal rain of literal molten glass that tears through the alien sky. Expanding our vision out to a much grander structural scale, we gaze upon the breathtaking majesty of the Pandora cluster, also known to professional astronomers by its catalogue name, Able 2744. This chaotic and incredibly complex cosmic structure is not a single entity, but is instead the direct result of a monumental, multi-generational pileup involving 4 independent galaxy clusters that have been violently crashing into one another over a span of roughly 350 million years. This ongoing slow-motion pileup has completely disrupted the local cosmic landscape, creating an intricate cosmic laboratory that stands out for its highly unusual and irregular distribution of dark matter. During these colossal galactic impacts, the invisible dark matter halos separating the clusters became separated from the luminous gas and entire galaxies, stretching across the system and pooling in completely unexpected, isolated locations. Because the Pandora cluster possesses such an absolute concentrated amount of physical mass, it exerts a truly monumental gravitational pull on the very fabric of space-time around it. This extreme distortion triggers a phenomenon known as gravitational lensing, where the cluster acts like a gargantuan, natural cosmic magnifying glass, bending and amplifying the incoming light from ultra-distant galaxies situated directly behind it. By using this natural telescope, modern astronomers can peer through the cluster to look back in time, revealing infant galaxies that originally formed shortly after the Big Bang. This brings us to a deeper investigation of the mystery of dark matter itself, a highly enigmatic and completely invisible substance that makes up roughly 27% of the entire mass-energy budget of the known universe. Despite its absolute dominance across the cosmic web, dark matter remains completely undetectable by traditional scientific instruments because it does not emit, absorb or reflect any form of electromagnetic radiation, rendering it totally invisible across all wavelengths of light. We cannot see it, we cannot touch it, and we cannot detect it with conventional telescopes. Yet, we know with absolute scientific certainty that it exists because of its unmistakable long-range gravitational influence on visible matter. Without the massive hidden gravitational scaffolding provided by dark matter halos, fast-spinning spiral galaxies like our own Milky Way would fly apart into deep space, as the visible stars and gas do not possess enough collective gravity to hold themselves together. Turning from the invisible to the highly theoretical, we contemplate the fascinating concept of wormholes. First proposed as a legitimate mathematical solution to Einstein's equations of general relativity, these hypothetical structures are envisioned as shortcuts or tunnels slicing directly through the fabric of space-time, theoretically connecting two immensely distant regions of the cosmos together. By travelling through a wormhole, an advanced explorer could instantly cross millions of light years in a matter of seconds, effectively bypassing the cosmic speed limit of light. However, the actual physical existence of these structures remains completely unproven and uncertain. According to our current understanding of physics, a wormhole is naturally predisposed to instantaneous collapse. To keep the throat of the tunnel open and stable for transit, it would require a substantial injection of exotic matter possessing negative mass and negative energy properties that defy all known conventional laws of physics. If a stable, traversable wormhole were to somehow exist naturally in the deep void, it would appear from the outside as a highly distorted, perfectly spherical bubble in space. Looking directly at its curved surface, an observer would not see a solid object, but would instead peer into a curved window, reflecting a completely different region of the universe. Approaching this anomaly and peering inside, the structure would look like a deep tunnel, which represents a highly compressed bridge of pure space-time itself. While astronomers have meticulously scanned high-definition images of distant galaxies and stars searching for unique gravitational distortions that might hint at a wormhole, every single anomaly discovered so far has been successfully explained by the presence of black holes or other massive, traditional celestial objects. We now return our focus to the one place in the wide cosmos that holds a completely unique status in human knowledge, our home planet Earth. Nestled safely within the temperate boundaries of our solar system's habitable zone, Earth stands as the only world in the entire known universe officially verified to harbour and sustain biological life. When viewed by astronauts from the deep darkness of space, our world presents itself as a striking, exceptionally beautiful blue sphere. This distinct planetary colour palette is caused by the vast, interconnected liquid oceans that cover over 70% of the global surface, paired with the natural Rayleigh scattering of starlight passing through our rich nitrogen and oxygen atmosphere. Over a long and dynamic timeline spanning more than 4.5 billion years, Earth's global climate, internal geology, and atmospheric composition have continuously co-evolved in extraordinary, deeply intertwined ways, establishing a wonderfully stable global environment that has successfully fostered an immense, dazzling biodiversity of life. Throughout its long history, the planet has transitioned through a variety of dramatic geological eras, enduring everything from its chaotic, completely volcanic origins to global ice ages where glaciers marched across the continents, with each successive era fundamentally reshaping the geography and driving the evolutionary tree of life into new frontiers. Sailing away from our blue sanctuary back into the deep stellar ocean, we locate the blinding brilliance of R136A1. This celestial beast stands officially as one of the absolute most massive and luminous stars ever identified anywhere in the entire cosmos, residing far outside our galaxy within the dense stellar factories of the Large Magellanic Cloud. R136A1 is a hypermassive Wolf-Rayet star that possesses an internal mass equivalent to roughly 250 of our suns combined, and it radiates a blinding light that is several million times brighter than our local sun. The sheer amount of physical energy being generated within its superheated core is almost incomprehensible. In fact, this single star blasts out more raw energy in a matter of a few seconds than our sun can manage to produce throughout an entire calendar year. However, because it lives such a radically intense and highly hyperactive existence, its lifetime is destined to be incredibly fleeting. While a stable star like our sun can husband its fuel to live for 10 billion years, R136A1 will exhaust its internal resources in a mere few million years before its core collapses under its own crushing gravity, triggering a hypernova explosion that will violently illuminate its entire host galaxy. We next travel roughly 1,500 light-years away from Earth to investigate the profound scientific mystery surrounding KIC 84628552, a completely unique F-type main sequence star popularly known across the globe as Tabby's star. In the year 2015, this otherwise ordinary star instantly captured the undivided attention of the global scientific community and the public due to its completely unprecedented, highly erratic brightness fluctuations, while regular exoplanets transit in front of their host stars and cause tiny, perfectly uniform dips in light. Tabby's star was observed undergoing massive, completely irregular drops in brightness that plunged its total light output by an unbelievable 22%. These erratic dips completely defy the traditional mathematical patterns of any known planetary transit. With no definitive scientific explanation available, a wide array of fascinating hypotheses were proposed, including the thrilling speculation that the phenomenon might be caused by an immense, artificially constructed alien megastructure, such as a developing Dyson sphere engineered to harvest the star's energy. Another leading, more conservative scientific theory suggests that these dramatic blockages are caused by an irregular, highly fragmented cloud of cosmic dust and fragmented cometary debris orbiting the star along an eccentric trajectory, sporadically blocking the starlight as it passes between the star and our telescopes. Continuing our journey through the realm of theoretical astrophysics, we ponder the mind-bending concept of an antimatter star. In theory, this would be a star composed entirely of positrons, antiprotons, and antineutrons rather than the traditional protons, electrons, and neutrons that make up normal matter. To a distant observer, an antimatter star would look completely identical to a normal star, emitting the exact same wavelengths of light and heat through internal nuclear fusion. However, because it exists within a universe that is overwhelmingly dominated by normal matter, its outer atmospheric boundaries would inevitably interact with the incoming interstellar gas streams, triggering violent matter-antimatter annihilation events that would unleash intense bursts of high-energy gamma radiation. While astronomers have actively scanned the night sky for these unique gamma-ray signatures, no direct physical evidence confirming the existence of an antimatter star has ever been found. If one were to be definitively identified, it would completely revolutionize our core understanding of cosmology, proving that large pockets of primordial antimatter managed to survive the early chaos of the Big Bang, without being annihilated. Our exploration now brings us to witness the terrifying majesty of a hypernova, a stellar explosion that represents the absolute apex of destructive power in the universe. A hypernova is an exceptionally rare and ultra-powerful variety of supernova that occurs when a truly gargantuan star, one possessing a mass greater than 30 times that of our Sun, reaches the absolute end of its life cycle and suffers a total core collapse, instantly forging a black hole at its centre. The sheer magnitude of the physical energy expelled during this collapse is staggering, violently hurling stellar material and superheated interstellar gas outward into the void at near relativistic speeds. This explosive shockwave can fundamentally reshape entire regions of space, stretching across dozens of light years, completely vaporizing and obliterating any nearby planetary systems that happen to orbit too close to the blast. Despite their terrifyingly destructive nature, hypernovae play an absolutely critical and irreplaceable role in cosmic chemistry. The extreme pressures and temperatures achieved during the height of the blast act as a cosmic forge, producing and dispersing heavy chemical elements like iron, nickel and gold, enriching the interstellar medium and providing the essential ingredients required to build future generations of planets and life. Sailing back toward the dense core of our own galaxy, we marvel at the spectacular density of Omega Centauri. Floating proudly as the absolute largest and most massive globular cluster associated with the Milky Way, this giant stellar metropolis contains an estimated 10 million individual stars packed tightly together into a single gravitationally bound sphere. With an estimated chronological age of roughly 12 billion years, Omega Centauri ranks comfortably among the absolute oldest structures in the known universe, serving as a preserved relic from the dawn of cosmic history. Because it is so extraordinarily massive and bright, it can be seen clearly with the unassisted human eye from the southern hemisphere, appearing as a soft, hazy patch of light drifting across a clear night sky. Within the inner boundaries of Omega Centauri, stars are packed together with a density that is thousands of times greater than our own local region of space, creating a surreal nighttime sky where neighbouring stars sit light weeks or light days apart rather than light years. Finally, we turn our gaze to the large Magellanic Cloud, a beautiful irregular satellite galaxy that hovers on the outer fringes of the Milky Way, at a distance of approximately 160,000 light-years. Visible to the naked eye as a faint glowing mist in the southern night sky within the borders of the Dorado and Mensa constellations, this companion galaxy is locked in a permanent gravitational dance with our own. Deep within its borders lies the magnificent Tarantula Nebula, a truly colossal and exceptionally active star-forming region that represents one of the largest and most energetic stellar nurseries found anywhere in the local group of galaxies, hosting clusters of infant giant stars that light up the intergalactic void. Continuing our journey through the vast celestial catalogue, we redirect our focus toward the legendary Pillars of Creation. Nestled deeply inside the heart of the Eagle Nebula, this iconic structural masterpiece represents one of the absolute most breathtaking, highly detailed star-forming regions ever captured by modern astronomy. The immense towers of cold molecular gas and dense interstellar dust stretch across multiple light-years of space, acting as a fertile cosmic incubator where brand new stars are continuously pulling themselves together out of raw materials under the slow, steady pull of gravity. The intricate, fine geometric features of these columns are continuously being sculpted, eroded, and peeled away by the fierce, high-velocity stellar winds and intense ultraviolet radiation blasting outward from supermassive newborn stars that have recently ignited in the immediate neighbourhood. When we observe these towers using the ultra-high definition infrared eyes of our most advanced space telescopes, we can clearly see tiny dense pockets of gas known as evaporating gaseous globules, or EGGs. These structures contain infant protostars that are currently fighting to accumulate enough matter to initiate nuclear fusion before their protective gas blankets are completely blown away into the void. We now direct our attention to the breathtaking and visually spectacular phenomenon known as a binary star system. Unlike our own solar neighbourhood, which is illuminated by a single solitary parent star, a vast majority of the stellar inhabitants across the Milky Way Galaxy actually develop in pairs, locked together in a permanent tight gravitational embrace. In these dynamic systems, two independent stars are forced to revolve around a shared common centre of mass, executing a perfectly balanced orbital dance that can last for billions of continuous years. This close physical proximity can trigger truly fascinating and highly complex stellar interactions, particularly in systems where one star has evolved ahead of its companion to become a compact white dwarf, a hyperdense neutron star, or a bottomless black hole. Under these extreme orbital configurations, the intense, short-range gravitational pull of the dead stellar remnant can physically distort the outer atmospheric layers of its living companion star, pulling a steady stream of hydrogen gas across the orbital gap to form a violently swirling, superheated accretion disk that radiates intensely across the X-ray spectrum. This structural interaction brings us to the study of gravitational waves, which stand as one of the absolute most profound and revolutionary discoveries in the entire history of modern astrophysics. First predicted mathematically by Albert Einstein in his 1916 General Theory of Relativity, gravitational waves are actual ripples or fabric distortions travelling through the literal geometry of space-time, propagating outward through the vacuum of space at the absolute speed of light. These subatomic ripples are generated whenever exceptionally massive, highly compact cosmic objects, such as twin black holes or binary neutron stars, undergo violent, rapid acceleration, such as when they are locked in a death spiral and spinning toward a colossal collision. As these companion stars move closer and closer together, both the physical frequency and the overall amplitude of these space-time waves intensify dramatically, sending out immensely powerful invisible pulses of gravitational energy that stretch and compress the fabric of the universe itself as they pass through individual galaxies. In such tightly packed, hyperactive binary configurations, the individual stars can be situated so incredibly near to one another that their outer layers of material may physically overlap or transfer directly from one star to the other. This phenomenon is scientifically categorized as a mass transfer binary, or a contact binary system, where the outer stellar envelopes fuse together to create a singular, peanut-shaped cosmic entity sharing a common atmosphere. This relentless exchange of matter can fundamentally alter the evolutionary life cycle of both stellar companions, sometimes choking the primary star and preventing it from undergoing its natural supernova phase, while simultaneously packing the secondary companion with so much stolen mass that it prematurely triggers a catastrophic stellar detonation. Our next destination brings us to gaze upon the spectacular beauty of the Twin Jet Nebula, which is also recognised across the astronomical community by its formal catalogue designation, Minkowski 2-9. This breathtaking planetary nebula stands out as an absolute visual marvel because its specific shape features two beautifully symmetrical, opposing lobes of glowing gas that extend outward into space like the wings of a colossal cosmic butterfly. This highly unique bipolar geometry arises directly from the presence of a central binary star system nesting deep within the heart of the cloud, where an aging red giant star is currently shedding its outer layers, while locked in a tight orbit with a tiny hyperdense white dwarf companion. From its central core, tightly focused, high-velocity spiraling jets of gas extend continuously through the opposing lobes, propelled in opposite directions at speeds exceeding hundreds of kilometers per second by the complex gravitational interactions and magnetic fields churning between the two stars. We now travel roughly 600 light-years away from our home planet into the deep stellar ocean within the boundaries of the Cygnus constellation to visit Kepler 22b. This fascinating alien world holds a sacred place in the history of astronomy because it was officially one of the very first exoplanets ever discovered residing directly within its parent star's habitable zone, meaning it sits at the perfect distance where temperatures are moderate enough to allow liquid water to exist on its surface. With a physical radius that is approximately 2.4 times larger than that of Earth, Kepler 22b is structurally categorized as a super-Earth, a type of planet that is completely missing from our own solar system, but appears to be incredibly common across the wider galaxy. Scientists project that this world might possess a remarkably dense, well-insulated atmosphere capable of sustaining vast global oceans and supporting highly complex long-term climate cycles. Its host parent star, Kepler 22, is a yellow dwarf star that is highly similar in chemical composition to our own Sun, though it is slightly smaller and noticeably cooler, suggesting that the exoplanet enjoys a thoroughly stable, temperate climate. Because Kepler 22b is a large, rocky planet, some theoretical models suggest that its internal geology would be exceptionally dynamic, featuring highly active plate tectonics and powerful mantle plumes that drive global geographic changes over millions of years. If this world is indeed a true ocean planet wrapped in a thick, protective atmosphere, its global environment would be beautifully suited to nurture and sustain some form of alien biology. The combination of a stable, sun-like parent star, a 290-day orbital calendar, and the presence of liquid water would provide the exact foundational building blocks required to spark the development of living organisms. The native species of Kepler 22b would evolve under the unique pressures of a world with a surface gravity that is significantly stronger than Earth's, forcing life to adapt to a dense fluid environment where buoyancy and structural reinforcement are critical to survival. If a flourishing marine and terrestrial ecosystem has managed to take root across the vast expanses of Kepler 22b, the native organisms would display truly spectacular evolutionary traits. For instance, we can imagine a colossal oceanic creature called the Thalassotitan, a gentle, filter-feeding leviathan that reaches the scale of a terrestrial island. This massive organism would glide gracefully through the deep global oceans, its body constructed from lightweight, highly flexible cartilage that allows it to easily withstand the increased hydrostatic pressures of the planet's deep water columns. To sustain its massive bulk, the Thalassotitan would feature an incredibly advanced wide-set mouth lined with thousands of fibrous comb-like structures designed to strain billions of microscopic, photosynthetic algae directly out of the water currents as it swims. Inhabiting the shallow coastal bays and floating island reefs of this world would be the Dendroflora, a fascinating hybrid organism that blurs the definitive boundary between plant life and animal life. This unique creature would root itself securely into the rich underwater volcanic soil, extending a series of wide leaf-like translucent sails up above the water surface to capture the golden starlight of Kepler 22 for photosynthesis. Simultaneously, beneath the waves, the Dendroflora would possess an array of highly active predatory tentacles covered in specialised stinging cells, using them to capture small marine organisms that drift too close, providing the creature with a dual source of vital nutrients. Prowling through the thick, humid atmosphere of the planet's isolated archipelagos would be the Aeropteryx, a highly agile, four-winged avian predator. To navigate and fly through an atmosphere that is significantly denser than Earth's, this creature would develop an exceptionally wide, reinforced wingspan paired with a hollow, honeycombed bone structure that minimises its body weight against the heavy surface gravity. The Aeropteryx would rely on an advanced multifocal visual system, allowing it to peer through the heavy atmospheric haze and pinpoint schools of native fish swimming beneath the ocean surface before diving down at high speeds to ambush its prey. Deep within the abyssal trenches of the global ocean, where no starlight can ever penetrate, the Chondrichthyes illuminates the darkness. This sleek, bioluminescent predator would feature a highly sophisticated network of glowing photophores running along the entire length of its lateral line, pulsing with a brilliant emerald green light to lure curious prey into its waiting jaws. Its eyes would be highly oversized and incredibly sensitive, engineered to detect the faintest micro flashes of biological light produced by other deep-sea inhabitants across the freezing, high-pressure plains of the ocean floor. We can also imagine the Geochelone, a massive, slow-moving reptilian herbivore that occupies the rocky volcanic landmasses of Kepler-22b to support its immense physical weight against the planet's heavy gravitational pull. This creature would evolve 4 exceptionally thick, pillar-like limbs anchored by wide padded feet that distribute its mass evenly across the rugged ground. The Geochelone would be completely encased in a heavily reinforced, multi-layered carapace that protects it from both falling volcanic debris and the intense ambient heat generated by the planet's highly active tectonic ridges. Finally, along the damp, moss-covered shorelines of the continents, the Brachyura would establish its sprawling colonies. This highly successful amphibious invertebrate would possess a heavy, calcium-rich exoskeleton that provides a natural shield against predators, paired with a specialised dual respiratory system that allows it to breathe with equal efficiency both underwater and in the open air. The Brachyura would act as a vital scavenger within the ecosystem, using its powerful asymmetrical claws to break down decaying organic material washed up by the tides, recycling essential nutrients back into the soil and water. As we reach the ultimate frontier of our astronomical journey, we must pause to reflect on the staggering scale and sheer diversity of the cosmos we have observed. From the rusted desert landscapes of Mars to the supersonic glass-raining skies of distant exoplanets, the universe continues to shatter every boundary of human imagination. We have witnessed the birth of newborn stars cradled within the opaque, majestic dust structures of the pillars of creation, and we have tracked the final violent demises of cosmic hypergiants, fueling spectacular hypernova blasts that enrich the interstellar medium with the foundational heavy elements required to forge future worlds. The deep space networks of galactic filaments, stretching seamlessly across hundreds of millions of light years, remind us that our entire solar neighbourhood is but a microscopic speck drifting through an unfathomably vast, intricately connected cosmic web. This brings our ultimate focus back to the ongoing search for extraterrestrial life and the deep scientific realization that our exploration has only just begun. The highly sophisticated robotic rovers, deep space probes, and advanced space telescopes deployed by humanity have merely scratched the surface of a glittering cosmic ocean as our technology advances, allowing us to analyse the atmospheric compositions of distant worlds like Kepler 452b, Gliese 667 cc, and Kepler 22b with unprecedented clarity, the probability of discovering a second biological sanctuary continues to grow. We stand on the precipice of a brand new golden age of discovery, where the boundary between theoretical speculation and verified scientific reality blurs more every day. Whether life out there exists as microscopic organisms thriving deep within subglacial oceans, or as complex exotic ecosystems adapting to extreme alien environments, the cosmos remains a limitless theatre of wonder, awaiting our curiosity. As we look ahead to the next centuries of human exploration, our eyes remain fixed on the deep void, driven by an innate, unceasing urge to understand our place among the stars. The magnificent nebulae, terrifying black holes, and pristine alien landscapes we have profiled are not just distant, isolated anomalies. They are the living history and the future destination of our species. We are a way for the cosmos to know itself, and as we continue to push our machinery and eventually our own footsteps into the deep dark, we carry the torch of human curiosity into the infinite, marvellous theatre of creation. Our long voyage through the grandest, most extreme corners of the explored universe draws to a close, leaving us with a profound sense of awe and an everlasting commitment to keep looking up at the night sky.